Hello, hello, testing 1, 2, 3. Let us vibrate by producing sound to feel the thrill of sound waves. Sound waves are produced by vibrating objects. The vibrating string of a guitar or piano produces sound. Energy from the vibrating source. The sauce here is not a chili sauce or tomato sauce. It is a source of sound. Is transferred to the surroundings by sound waves. The frequency of the sound wave is the same as the frequency of vibration of the source. The normal audible frequency range of a person is about 20 Hz to 20 kHz, and the speed of sound in air is about 330 meter per second. Sound wave is a longitudinal wave which require a medium for its propagation. Sound can travel through a gas, liquid or solid. I repeat again, sound can travel through a gas, liquid or solid. Let us see standing waves along a stretch string. In musical instruments, sound is caused by standing waves. Let us see an example of a stretch string in a guitar. When the midpoint of the string is plucked, or we just quickly pull and released at this midpoint. So now the string is vibrate. It will vibrate in this form. It forms waveform with and, a and, not, anti-not and not. For the formation of standing wave, not, anti-not, not, anti-not, not. Not anti-not is quarter wavelength. Anti-not to not is quarter wavelength. Not anti-not, quarter wavelength, and finally another quarter wavelength will gives you 1 lambda. So it means not to anti-not is quarter wavelength. So for string, from not to anti-not, it gives you quarter wavelength. So it is similar for this formation of standing wave. So from the standing waves along a stretch string, we're going to find fundamental mode. of fundamental frequency. So from v equals to f lambda, this is the speed of wave propagation, the fundamental frequency. And for these stretch string we have quarter lambda, not to antinode to knot, another quarter. So the length between two nodes is alt. So the length here equals to quarter lambda plus quarter lambda half lambda. So lambda itself is 2L. So this lambda you can substitute here. So V equals to F naught 2L. So F naught equals to V over 2L. This is fundamental frequency or lowest frequency for this stretch string. Fundamental, mode, or fundamental, frequency. For the same stretch string, if we pull it harder at this midpoint or pluck it harder at this midpoint, the vibration of the waveform is stronger. Probably it forms two antinodes. Just now for fundamental frequency is just one antinode. Just one antinode. If we pull harder, it turns to be two antinodes. Just can be like this. So you can see two antinodes. Of course, the fixing point is node, no displacement at all. So we know that node to antinode is quarter wavelength. So quarter wavelength, so another knot here, quarter wavelength, and quarter wavelength. So 1, 2, 3, 4 all together 4 times quarter wavelength will give you just one wavelength. So now the length equals to lambda. Just now is a fundamental mode. And now is about first overtone, or we call it formation of two antinodes. So from speed of wave propagation for first overtone, V equals to F1 lambda equals to L. First overtone frequency equals to V over L. If we want to put F1 in terms of F0, so we know that V over L equals to 2 F0. So V over L is equals to 2 F0. So F1 equals to 2 F0. So this is first overtone, for second harmonic. So these two here form second harmonic for first overtone. For the second overtone, if we pluck it a little bit harder than the first overtone, it forms three antinodes. Three antinodes with note, note, note and note. So we have 1, 2, 3, 4, 5, 6. 6 times formation from note to antinote. So 6 times quarter wavelength. This is wavelength from note to antinote. So 2, 2, 2, 3. So we will get 3 over 2 lambda. Let it be the length from 2 fixed point is L. So L equals to 3 over 2 lambda. From the speed of wave propagation for second overtone, here lambda equals to 2 over 3L. So we can substitute the lambda in this equation. V equals to F2 2 over 3L. So second overtone frequency equals to 3V over 2L. So if we write second overtone in terms of F naught here is V over 2L. V over 2L. So V over 2L is F naught. So F2 equals to 3F naught. This is second overtone. For third harmonic. So the sequence will be F naught, F1, F2 and so on. If you want to put all into fundamental frequency terms or in terms of fundamental frequency, so F naught, F1 will be 2F naught, 3F naught and so on, because F1 is 2F naught, so F1 2F naught, F2 is 3F naught, so F2 is 3F naught. Simple like a bubble without giving you any trouble. We can do the same process for F3, F4 and so on. So the fundamental frequency become first harmonic, second harmonic and third harmonic. Followed by F3 is 4F naught and F4 is 5F naught. If you blow softly across the open end of a test tube, sound of a certain frequency is produced. When you blow harder, the sound produced has a higher pitch. Figure A shows longitudinal wave traveling towards the close end and is then reflected. Superposition of the incident wave and reflected wave produces stationary longitudinal wave in the closed pipe. Figure B shows the instantaneous displacement of air molecules along the axis of the pipe in the fundamental mode of vibration. Particle 3 at the open end has the greatest displacement. The displacement of particle 2 and 1 becomes smaller. And finally, the particle O at the close end is not displaced at all. Figure C shows the displacement distance graph for the stationary wave drawn inside the tube. This graph shows the fundamental mode of vibration. The sound emitted is known as the fundamental note. This is the formation of stationary wave in air column, or we call it closed pipe. And also we call it as the fundamental mode of vibration. So for the closed pipe, I can show you again how the formation of the wave form. You can see clearly. By drawing the waveform for fundamental mode. This is not no displacement at all, and this is anti-naught, forming maximum displacement. So from naught to anti-naught equals to quarter wavelength, and the length of the tube itself is L. So by using the formula of V equals to F lambda, this we call speed of wave propagation, where F is a fundamental frequency. So we know that L equals to quarter wavelength. So the wavelength itself is for L. So we can substitute this lambda in this formula. So we will get V equals to F naught for L. So now we can find the fundamental frequency F naught for this closed pipe is equals to V over 4L. Fundamental frequency is the lowest frequency. Obtain. When you blow harder across the open end of pipe, notes of higher frequencies are obtained. Is about first overtone, which is F1. Again, everyone knows that naught to anti-naught is quarter lambda or quarter wavelength. So for the first overtone, the formation of waveform is about 2 knots and 2 anti-knots. So the length of the pipe is quarter wavelength times 3. Quarter wavelength plus quarter wavelength plus quarter wavelength. So times 3. So the length is 3 lambda over 4, which is the lambda equals to 4L over 3. From the speed of wave propagation, V equals to F1 times lambda, where the lambda itself is 4L over 3. So finally, the first overtone is equals to 3V over FL. If we want to put F1 in terms of F0, we know that F0 is equals to V over 4L, which is lowest frequency obtained. I repeat again, F0 equals to V over 4L. So, V over 4L equals to F0. So, F1 in terms of F0 is 3F0. F1 is first overtone and the 3 here is third harmonic. When you blow a little bit harder across the open end of pipe, notes of higher frequencies are obtained again. Now is about second overtone, which is F2. So note to antinote is quarter wavelength. So now we have 1, 2, 3, 4, 5 notes to antinotes, which means we have 3 antinotes and 3 notes. 3 antinotes and 3 notes. So now the length is quarter wavelength times 5, where the length is 5 over 4 lambda. So lambda itself is equals to 4L over 5. So the speed of wave propagation V equals to F2 times lambda. F2 is second overtone and lambda is 4L over 5. Lambda is equals to 4L over 5. We substitute in this equation. Then you will get the frequency of second overtone is equals to 5V over 4L. We know that it is crystal clear that F0 is V over 4L, which is lowest frequency. F0 equals to V over 4L. So, for F2 in terms of F0, V over 4L is F0. So F2 equals to 5 F0, which is F2 is second overtone and 5 is the fifth harmonic. You can write F0, F1, F2 continuously in a mathematical terms and also in terms of F0, which is F0, 3F0, 5F0 and so on, which are all odd harmonics. Simple like a bubble without giving you any trouble. Standing waves can also be produced in an open pipe at both ends in the same manner as standing waves in a closed pipe. For this fundamental frequency, or we call it fundamental mode, with 2 antinodes and 1 note. Antinote to note is quarter wavelength, so the length equals to quarter wavelength times 2. Antinote to note quarter wavelength, note to antinote quarter wavelength, so we have to times 2. So the length is half wavelength. So then you get wavelength equals to 2L. From the speed of wave propagation, v equals to f naught times lambda, where lambda equals to 2L times f naught, and finally f naught equals to v over 2L. This is we call fundamental frequency or fundamental mode, or we call it lowest frequency. And then for the first overtone, the wave is a little bit strong, which we have 3 antinodes and 2 nodes, whereas for fundamental frequency we only have 2 antinodes with 1 node. So for the first overtone, antinode to node is quarter wavelength. So we have 1, 2, 3, 4. So we have to times 4 with quarter wavelength. You will get length equals to lambda. From the speed of wave propagation, v equals to f1 lambda. F1 is first overtone, where lambda equals to L, and finally f1 equals to v over L. f1 in terms of f0 is 2f0, because f0 itself is v over 2L. So v over L is equals to 2f0. So v over L is 2f0. For the second overtone, we have 1, 2, 3, 4 antinodes and 1, 2, 3, 3 nodes. So the length now is 6 times quarter wavelength. 1, 2, 3, 4, 5, 6, 6 times quarter wavelength. Then you will get the length is 3 over 2 lambda. And again, from the speed of wave propagation, v equals to f2 lambda. F2 is second overtone, and lambda itself equals 2L over 3. Here lambda equals to 2L over 3. I can substitute this lambda into this equation formula. So we will get v equals to f2 times 2L over 3. And the fundamental frequency here, f0 equals to v over 2L. So v over 2L is f0. So f2 equals to 3 f0. So second overtone in terms of fundamental frequency is equals to 3 f0. So now you can see the sequence of this open pipe, which is similar to the stretch string. So this is a fundamental frequency, second overtone and third overtone and fourth overtone and so on. So this is first harmonic, second harmonic, third harmonic and fourth harmonic. Thank you for watching this video. Thanks a lot, and thank you to the Lord.